Hi everyone. So I want to talk about closure property, and this is hopefully going to be a quick video. So the property of closure is really super mathematical and really super intense and really and truly difficult to understand. So I'm going to make it as easy as possible. So we're talking about polynomials and specifically operations with polynomials. So polynomials are closed under three of the four major operations. Polynomials are closed under addition, subtraction, and multiplication. Now great, what does that mean? So basically that means when there are specific parts of a set or specific parts of a problem, or really and truly a problem in general regarding polynomials, and let's take addition first. The answer or the sum of those parts is the same as one of the original pieces of the original question, meaning nothing major has changed with regards to adding them. So I added a couple things together, and my answer or my result is still something that would belong in that same set as I started. So let's take something for example. So let's say I had something real simple, 2x squared plus x plus 4x minus 3x squared. Okay, so the plus sign stays, the parentheses will drop. 2x squared minus 3x squared is negative x squared, and 1x plus 4x is 5x. So since this is the answer, both of those terms would still belong in the same set as up here. Because for instance, x squared or square, the 2 exponent is my highest degree. The 5x would certainly belong with the x and the 4x. So nothing has changed there, okay, with regards to the ending results and like two of the beginning questions or two of the beginning parts, okay? Let's take a look at subtraction. Make it real simple. If I just put a subtraction sign in the middle of these two things, polynomials would still be closed, okay, because then I would distribute the minus sign. Like terms would be a 1x minus a 4x would be a negative 3x. 2x squared plus 3x squared is 5x squared. That's my answer if that was a subtraction problem. Still closed under substitution, or I'm sorry, subtraction. Nothing changed here, okay? I've got a square, which is my highest degree, and I've got two terms, both have terms or similar terms as what I start with. Multiplication is no different, okay? It's the same exact thing. Now, this might look a little funky, but let's say I had this. If I FOILed this out or multiplied the binomials, I would get x squared minus 4x plus 3x minus 12. Combining the two middle terms, x squared minus x minus 12. Now, you're saying, well, now it's a square. Yes, but it's still within the same construct of having a exponent here that would be 1 and 1, okay? So we're closed under these three. Division is the one that makes it completely different. Now, there's one reason why, and one real reason why, it is not closed under division. And it would be something, I'm going to try to explain this better in class, but what if I had 3x divided by x, and we found out that x was 0? X can't be 0. But 0 is a number, and 0 can fit into one of these two x values, or both these x values. So I can't have this. This is not determinable, okay, so indeterminate. Or it's an error. We can't divide by 0. It's a divide by 0 error, okay? So it would be no solution, or it would be undefined slope, that type of thing. This is why division is not part of the closure property, because it doesn't work with regards to having one instance, this one key specifically, that doesn't make it true, okay? So when we talk about closure property, we talk about division not being a part of that. Now, division is not only not part of closure for polynomials, it's also not a part of the closure property with regards to integers. Because again, if I have division and the bottom is 0, not going to happen, okay? So we'll talk a little bit more about closure in class, but otherwise, that's a wrap. Bye. Bye-bye.